This is our video of us investigating the wetting and emulsifying properties of detergents, and we're using soap as an example. This is to investigate the wetting property. Here we have two pieces of paper, nearly identical, and we're going to put a drop of water in each of these pieces of paper, and one side will have soap on it. Okay. One drop and two drops. As you can see, the results from the two sides are very different. On the side with no detergents, the water droplet basically is still solid, and it does not spread out and wet everything. However, the other side, the side with detergents, as you can see, the drop of water has spread out a lot more than the one with no detergents. And this proves that soap and detergents in general has a wetting property. Is our proof. As you can see, without detergent, water droplets are concentrated towards the center on a piece of cloth or paper. Intermolecular forces include the hydrogen bonds and van der Waals force. You see, without detergents, the molecules in the drops do not spread, and as a result of high surface tension in water, the drop holds together. However, if there is detergent and water at the same time on a piece of cloth or paper, the detergent reduces surface tension of water droplets, allowing the water to spread over the cloth. In essence, it breaks through the water's tension and allows it to spread. And so with water spreading over the cloth is wetted more easily. So to conclude, detergent and soap is a wetting agent. Investigating the emulsifying properties of soap. Now, this student has a bottle of water. Now we are going to put some oil into the water. Now, you see, there is oil in the water, and the oil has formed droplets. Now we are going to close the bottle, and the student is going to shake it. Alright, as you can see, the oil has formed a surface near the surface of the water. It's broken down into droplets. Due to time constraints, we cannot show the eventual result of leaving the oil to stand here. But if the oil is left standing with the water, it will eventually form a layer of oil once again. To add detergent into the water with oil. Now, the detergent, as it slowly dissolves, and will cause the oil to stay as a droplet instead of turning back into a layer again. If it is left standing, you'll find that the oil will never be able to form a droplet. Will never be able to form a surface from the droplets again, as the detergents prevent the droplets from solidifying. Shaking it up, and now there's a very big layer of foam. This layer of foam basically blocks the oil so that the oil, now trapped in the water, cannot reform a layer. As you can see, even at the point of contact between the foam, that is the detergent, and the water, you will not see a layer of oil. The diagram for the emulsifying property of detergent. First, without a detergent. Without detergents, when you put a layer of oil on top of water and then shake it, the oil will form droplets that will dissolve into the water. However, if left to stand for a while, this mixture will eventually separate until a layer of oil is formed back on the surface of the water again. This is because water has polar molecules, but oil has nonpolar ones. So water and oil can't mix well. That's why when you shake a mixture of oil and water, an unstable emulsion will form. However, when this mixture is allowed to stand for a while, it will separate. Now, what happens if there is detergent? If there is detergent, and you put a layer of oil on top of the water followed by detergent, once you shake it, there will be emulsion as well. And the oil droplets will mix with the water. However, the foam from the detergent will block the surface of the water and prevent the oil droplets from reforming into a layer of oil. As the tails of detergents are hydrophobic, which means they do not mix well with water and they dissolve in oil, while the heads of the detergent molecules are hydrophilic, which means they dissolve in water and mix with water well. And as you can see, emulsified particles cannot join together when you put detergent in it, as it is very, very negatively charged. That is why detergents can emulsify oil, as the detergent will form a layer of negative ions on the oil surface, causing them to repel each other. Therefore, they cannot form a single layer of oil again. Thank you.